I don't know here.
Okay, before that, let me introduce myself. My name is Muhammad Chika Zaulhaq. Here I will explain about the modus ponens law. But before that, I will explain a little about the inference method in informatic logic.
Jadi kan dia jadi pindah.
Inference method in informatic logic. Inference is a method for drawing logical conclusion from one or more statement now known to be true in computer science. This method is essential for knowledge processing, artificial intelligence expert system, and computer program verification. Okay, alright everyone. Now we will discuss modus ponens, also known as the laws of the attachment. Modus ponens is one of the basic rules in logic used to draw valid conclusion. One general form, modus ponens has the following general form: if P, then Q, and P is true, then Q is also true. This means that when we have a statement if P then Q and we know that P is true, we can conclude that Q must also be true. Example, the example shown is the material is premise 1. If it rain, then the road is wet. P then Q. Premise 2. It is raining now. P conclusion. Therefore, the road is wet. Q. Logical explanation. This conclusion can be drawn because there is a cause and effect relationship. Rain cause the road to be wet. The cause which is rains is happening. Therefore, the effect which is Q with road can be considered be true. Main point, in essence, modus ponens law used to draw conclusion based on a clear cause and effect rule. As long as P is true or occur, then Q as result must also be true. Okay, thank you.
Hello, let me introduce myself. My name is Dina. Here I will explain the material onto modus tollens. Modus tollens general form. If P then Q and Q is false, then P is also false. Example, premise 1. If the computer is on, then the power light is on. P if Q. Premise 2. The power light is not on, not Q. Conclusion. The power is not on, not P. Use to conclude the rejection of the condition from an unmet result. Thank you.
Yeah. Good evening. So, thank you for attending the class today. Going to talk about the inference method, of which I'm going to explain one example of inference method, which is hypothetical isologisms. So, there are more than 5 examples of inference methods, but I've taken only one. I'm going to explain today hypothetical isologisms. So that's what I'm going to explain. To start that, I will first like to introduce my name. I'm by name Achar. So I'm going to explain inference method and example of inference method. So to start that, I would like to first define the inference method. Inference method is a process that draws the conclusions of an argument. So they depend on the evidence of the arguments or the reasoning of an argument. So inference method only draw the conclusions of an argument based on the evidence and the reasoning of the argument. So there are more than 5 examples of the inference method, of which I'm going to explain the hypothetical isolations. Hypothetical isolations is the is a deductive argument that used at least one conditional statement or an if-then to reach the conclusion of an argument. So that is what hypothetical isolations mean. So to start that, I will give one example of these hypothetical isolations. So let me start with one example before I talk of what I'm going to talk about today. So if I give one example of that, if I can say if John study hard, then John will pass the test, and if John passes the test, then John will pass the class. If we can all see that statement or that argument, if John study hard, then John will pass the test, and if John passes the test, then John will pass the class. In that argument or in that statement, premise 1 is true, and if we can see in premise 2, like if John passed the test, then the John will pass the class. It doesn't guarantee if he's passing the test will make him pass the class. So premise 2 is not the guarantee. No, it is not true. So it depends. It doesn't mean if premise 1 is true, then premise 2 is also going to be true. So let's go and see this example. So the general method, premise 1, if the file is corrupted, then the program failed to run. So in premise 1 here, in all system or in the computer, if we can see, like if the file is corrupted, so there are a lot of things that can corrupt the file, like the power failures, the hardware issues, or the software errors. So those materials or those errors can interrupt or corrupt the file. Then if they corrupt the file, then the program will fail to run. So definitely it means that P imply Q is true. So premise 1 is true, and because it is true, because if the file is corrupted, then the program failed to run, because if there is a power failures in this system or a computer, or if there is a software errors or hardware failures in this system or computer, then it will definitely brings the program failures in this computer. Definitely to mean that if the file is corrupted, then the program failed to run. So P imply Q is true. So premise 2, if the program failed to run, then the system is in error. So Q imply error. If the program failed to run, like if we go to premise 1 here, it is here. If the program failed to run, then the system is in error. Like if the program failed to run, the system is in error, because if there are most failures or the power failures, the software errors, or the hardware failures in the computer, so all of them can be an error of the system, which means premise 2 is true. So in conclusion, if the file is corrupted, then the system is in error. So which means the conclusion is also true. And as you can say before, if premise 1 is true, definitely mean that the conclusion must be true. It is what we all know in inference method. If the premise 1 is true, then the conclusion must be true. And if we see here, if the file is corrupted, then the program failed to run, which means P1 is true, then the conclusion must be true. So if you try to see here, R is true because Q is true here. But if Q was false, like the program failed to run, because if the file is corrupted, then the program failed to run. This is true. But if Q was false, then R must be false here. But here, since Q is true, then P2 must be true. Premise 2 must be true. So, and if premise 1 and premise 2 are true, then the conclusion must be true. So, which means the argument of this statement or this argument is valid, which means it definitely it is true. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today we're going to talk about a disjunctive syllogism, which is a statement where if P or Q and that P is false, then Q must be true. For example, the computer is in sleep or shutdown mode, P or Q, and the second premise is the computer is in sleep mode, and the conclusion is that the computer is in shutdown mode. And this is useful to selecting one correct possibility from two conditions. Since even though Q can be false, if your only information is that P is false and that it's P or Q, then it's generally a good thing to assume that Q is in fact true. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thanks for the time is given to me. My name is Ignatius Tolok Open. I'll be explaining about conjunction. Slide 1. What is a conjunction? Let's start by understanding what a conjunction is. A conjunction is a compound statement combines two simple statements with the word and. In logic, we represent a conjunction with the symbol and. A conjunction is true and only if both of the individual statements are true. If either one or both statements are false, the conjunction will be false. Slide 2. General form of a conjunction. The general form of conjunction look like this: P and Q. 1. P is the first statement. 2. Q is the second statement. 3. And P and Q represents the conjunction, meaning P and Q. So we combining these two statements with the word and. Slide 3. Example of a conjunction. Let's look at an example to make this clear. 1. Premise 1. P. It is raining today. True. Premise 2. Key. I broke an umbrella. True. So the conclusion is it is raining today and I broke an umbrella. Since both premises are true, the conjunction P and Q is also true. Slide 4. When is a conjunction true? A conjunction like P and Q is only true when both P and Q are true. If either P is false or Q is false or both are false, then the conjunction will be false. So for the conjunction P and Q to be true, both parts need to be true. Slide 5. Conclusion. To wrap up, a conjunction is basis concept in logic used to combine two statements. Understanding how conjunction work helps us make valid arguments and draw conclusions based on the true false of individual statements. Thank you.